Okay, so here's sort of a thought experiment, kind of help hit home with this idea of exponential growth versus linear growth. So there's certain assumptions we make when we are given these sort of situations. So let's go through this problem together and sort of answer the question together. Suppose you place a single bacteria in a bottle at 11 a.m. It grows and 11:01 divides into two bacteria. These two bacteria each grow and 11:02 divides into 4, which grow and 11:03 divide into 8, and so on. Now suppose the bacteria continues to double every minute and the bottle is full at 12. The number of bacteria at this point must be 2 to the 60 because they double every minute for 60 minutes. But the important fact is that we have a bacterial disaster on our hands. Because the bacteria filled the bottle, the entire bacterial colony is doomed. The disaster occurred because the bottle was completely full at 12. When was the bottle half full? Okay, so we're going to talk about choices here and see if we catch that. Half full, well, you'd probably think it took an hour to fill the whole bottle up. So if it took an hour to fill the whole thing, then it must have been half full at 11:30. Okay. And if you happen to think that, I'm just going to go and tell you now that you are wrong. Okay, sad face. And here's sort of the reasoning behind why you're wrong, and then we'll go back and take a look at the problem again. What are we assuming when we say if it's full at noon, it's got to be half full at 11:30? We're assuming it's a constant growth, that the same amount is added every single minute. And so we're assuming that if it took an hour to fill the whole thing up, then it must have taken a half hour to fill half of it up. That's a linear growth. But take a look at this particular problem. Okay, it's doubling every minute. And since it's doubling every minute, this is an exponential growth. Okay, so if it's an exponential growth, right, doubled every minute, if it was full at 12, then it take half of that away. It must have been half full at 11:59, because in that 1 minute it must have doubled. Okay, so that's sort of the sort of watch out when you do these assumptions, is that when we think that it's a linear growth, we sort of understand that what that means, but just be careful when you're comparing linear versus exponential. How many bottles would the bacteria fill at the end of the second hour? Okay. Well, it took 1 hour to get one full bottle. Right. So again, watch out for your assumptions on this. So if it took 1 hour to fill a full bottle, you would think it takes 2 hours. You would have two full bottles. But again, that's a linear growth assumption. Remember, this bacteria is doubling every minute. So at 2 hours on the dot, you have one full bottle. At 2 hours and 1 minute, you have two. At 2 hours and 2 minutes, you have four. 2 hours and 3 minutes, you have eight. So it's doubling every minute. So in 60 minutes, you'd have 2 to the 60. Now, I'm going to try this on my calculator. Your calculator may or may not be able to do this. 2 to the 60 power. Let's see what it does. Look at that. I get this lovely number here. So 1 point, we're going to go scientific notation here. 1.15 times 10. And then we'll come back in and count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 1 to the 10 to the 18 power. You'd have that many bottles filled at the end of the second hour. That is a huge number. Okay, so in summary, what are some things to remember or to recognize uh, to exponential growth? One idea is that exponential growth leads to repeated doubling. It's very easy to double when you're talking about exponential growth of some kind. Uh, the amount of increase is equal to the sum of all preceding doublings. Amount of increase is the sum of previous doublings. And then exponential could theoretically exponential growth continue on forever and ever and ever? Well, the answer is no. Things that grow exponentially have to have some sort of limiting component. Otherwise, the Earth would be filled with things at this point. And yet, we measure things and we can see that they double. So, exponential growth cannot continue indefinitely. Only there's some sort of limiting factor that would prevent it from continuing to expand. Sorry, prevent from. And sometimes we actually don't know what that is. We don't know what makes it stop, but we definitely can track it in the short run.